Hello everyone! I am peaking way loud. I'm so sorry. Hello everyone. How are you all doing? What the fuck is up with my audio? Wow. Okay. Hello everyone. How are you doing? I have no idea why my audio is so loud tonight. Sorry about that. Yeah. Hello Null Pointer. Hello Ender Zombie 102. Hello Game of the Robot. Wonderful to see you all. There. Moving my mic further away. That's better. Okay. Might still peak a bit. I know what's going on. Something weird. Yeah. In any case, yeah. It's time for my last stream of the year. 2021 has been a shit year just all around. I don't need to talk about why, but I've had a really good time streaming this year. I've had a really fun time, and I'm excited for another wonderful year of streaming. But before that happens, I've got one stream left. I'm gonna learn how to use Rust. I'm gonna figure out why the fuck my audio is still big. Yeah. Also, yeah, Mr. Mangahan, thank you very much for the follow. Welcome to the network. I am now at 596 followers here on Twitch. If I can get to 600 by the end of the night, I would really appreciate that. I might do something special or fun from it when the new year starts. Yeah, without further ado, how about we just get going? Hey. So, over here on the left, I have the Rust book. This is like the thing to learn how to use Rust. Over on the right, I've just got VS Code. This is where I'm going to be like doing my development. Yeah. How about we get going? I've already installed Rust before all this. So, how about we just get started? So, I think I'm going to start out with cargo because this will like just make the directory for us. So, cargo, new, Rust, hello, alright, Rust, hello, I can open that folder up. I'm the author. Yeah, alright, now we got main.rs, got getting your cargo cargo lock, and we've got extra stuff. Yeah, Rust good. Yeah, I am very excited to learn how to use Rust. I have not gotten a chance to write it before, so this is gonna be fun. Right, so, yeah, let's create a new project using cargo and look at how it differs from our original Hello World project. Yeah. Isn't Rust C++ but actually good? Somewhat, yeah. Wait, hello, Cello, wonderful to see you. Yeah, that's like, from what I know, that's like a pretty alright description. Suggest starting with something simple. Yeah, no, yeah, Ender, I am going to be following along with the Rust book. Yeah, sound a bit far away from you, right? Alright, there, pulled it in, like a game engine. Yeah, yeah, I am trying to figure out, like, there's just been some weird stuff going on with my mic. It's just been, like, peaking, like, it was peaking randomly a bit ago. Now, I was apparently much better. Yeah, no, I just literally moved my mic closer. But, like, there's just, for some reason, it was just, like, peaking a lot. Excellent. I will now throw C++ into the trash. Yeah. Rust. For the folks who are not aware of it, yeah. going up and down with the volume, yeah. I don't know what's going on there, so oh well. Like, just triple checking. Input is, yeah, like, okay, yeah, like, just making sure, like, it is coming through my studio mic. It's not like my headset mic or whatever, so I don't know what's going on there. Oh well. Stuff is just gonna happen, yeah. For those who don't know much about Rust, it is a really interesting, language. Um, yeah, yeah. It is a, compiled programming language. Um, it can both compile just to, like, native machine code and to WebAssembly. While running native, it is, it does not have a runtime it does not have a runtime VM or a garbage collector. It doesn't have automatic reference counting. It is memory safe at compile time. And it's just, yeah, damn, Wasm, yeah, Wasm is the best asymmetric line. Wasm is interesting. Still not sure how I feel about little endian base 128, like, numbers. Like, in Wasm, all integers are variable width, but okay. Yeah. 502 SSM, yeah. Yeah, no. The most powerful weapon Rust has at its disposal is the Rust compiler, which is so fucking cool and powerful. Yeah. Heard you're learning Rust. Yes, I am learning Rust tonight. I'm very excited. Yeah, no, the Rust compiler is incredibly powerful, and I am very excited to give it a look. Yeah. How about there? Wasn't it the bar checker? Yeah, that's one of the things. Rust makes my joints hurty. Yeah, same. Yeah, hello, Cordy. Great to see ya. Yeah, so, here we go. Just set down as far as that. Alright, enough. Yeah. Okay, so, cargo.toml in your editor of choice should look similar to the code listing in 1.2. Yep, so, name Rust hello, version 010, edition 2021, dependencies empty. It's Toml, way. Yay. Bar checker's the worst part of Rust besides the syntax of the language itself. Starts to see programmer throwing shade, yeah. From stall stop here. Yeah, hello, Non. Great to see you, yeah. I don't know how, but I managed to resolve one of the Advent of Code days with Rust Fun, yeah. Yeah, borrow checking is an interesting quirk with Rust. It is basically just like, it is how it manages to be compile time memory safe. It's interesting, yeah. Yeah, yeah, last line dependencies. Start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. Won't need any other crates for this project, but we'll in the first project in chapter 2, so we'll use this dependencies section then. Open source main.rs and take a look. Alright, yep, that's what we got. Cargo's generated a Hello World program for you, just like the one we wrote in listing 1.1. Which I didn't do because I wanted to just like create one file to open in one project open in VS Code. Yeah. So far, the differences between our previous project and the project Cargo generates are that Cargo placed the code in the source directory, and we have a cargo.toml config file in the top directory. Rust bar checker's weird, wild, and wonderful, though Scholars are telling me it's 10-year-old tech. Yeah. Cargo expects your source files to live in the source directory. Top-level project directories just for README files, license info, config files, and anything else not related to your code. Using Cargo helps you organize your project. There's a place for everything, and everything is in its place. If you start a project that doesn't use Cargo, as we did with the Hello World project, you can convert it into a project that does use Cargo. Move the project code into the source directory and create an appropriate cargo.toml file. Alright, now let's look at what's different when we build and run Hello World with Cargo. Right, so... No, that's everything. Right, so I can just run cargo build. Building. Alright, yep. Command creates an executable file in target debug hello cargo. Or press hello.exe. Yep. Or, yep. Rather than in your current directory, you can run the executable with this command. So, yeah, so then I can just do /target debug cargo hello.exe. Whoop. /target bug cargo.exe. Rust hello, not cargo hello. Hello world! Yay, it works! That's code! Yeah, all goes well, hello world should print into the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo.lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file's a bit sparse. As in, yeah. Pretty basic, yeah. You don't ever need to change this file manually. Cargo managed its contents for you. Just build a project with cargo build and ran it with target debug hello cargo, but you can also just use cargo run to compile the code and then run the resulting executable all in one command. Notice that this time we didn't see output indicating cargo was compiling hello cargo. Cargo figured out the files hadn't changed, so it just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it, and you would have seen this output. Cargo also provides a command called cargo check. Yeah, it checks your code to make sure it compiles, but does not produce an executable. That's neat. Yeah, I have a love-hate relationship with the bar checker. Yeah, it's weird. Yeah. Okay. Ooh! Gamma redeemed. Give Lemma compliment quote. Yo, I have lots of points now. Lemma, you're so dang cool. I'm seriously considering making a GB game because of you, and I really hope that one day I can be as cool as you. Oh, thank you. That really means a lot to me. Thank you so much, Gamma. Yeah. Why would you not want to build an executable? Often cargo check is much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing code, using cargo check will speed up the process. As such, many workstations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use it. It's been too long, I'm not drunk. Hello, Jasper! Wonderful to see ya! Yeah. Alright, yeah. Yeah, so let's recap what we've learned about cargo. So cargo build, run, check, yep, target debug. Alright. An additional advantage of using cargo is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux, macOS versus Windows. Alright. When your project is finally ready to release, you can use cargo build --release to compile it with optimization. This command will create an executable in target release instead of target debug. The optimizations make your Rust code run faster, but printing them on lengthens the time it takes for your program to compile. This is why there are two different profiles. One for dev, when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build release and benchmark with the executable in target release. Happy New Year, you beautiful bot, you. Oh, thank you, Jasper. Yeah, Happy New Year, too. With simple projects, cargo doesn't provide a lot of value for just using Rust C, but it will prove its worth as your programs become more intricate. With complex projects composed of multiple crates, it's much easier to let cargo coordinate the build. Even though the Hello Cargo projects is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, work on any existing projects, you can use the following commands to check out the code using Git, change to that project's directory, and build. It'll just be git clone, cd, and build. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust using RustUp, already did that. Update to a newer Rust version, open locally installed documentation. I should probably go back and check that. Local RustUp doc, okay, got it. Well, let's go. What Rust are you running? This is, yeah, Cargo 150, so I am currently on, yeah, RustUp version says, yeah, RustUp 124.3 and Rust C 157.0. Alright. Not heard of RustUp doc until now, yeah. Looks to be cool. Alright. So, I'm just gonna keep working in this project just because it'll be a lot easier for me, so I don't have to open tons of different folders in VS Code. Yeah. Alright. So, got all this, got the first main RS, okay. Alright, yep, this will do the hello world with cargo run. Reopen first main RS, you'll be writing all the code in this file. Yeah. You know, we'll be implementing Placer. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, using external traits, and more. The following chapters will explore these ideas in more detail. In this chapter, you'll practice the fundamentals. We'll implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. Will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Yes. Rust book implying Hello World is not a real program. Yeah. Well, no, it means that, it means it'll show you how to use the concepts in a real program instead of just theoretically. Like, we aren't this fun main doesn't use let, match, methods, or anything. It's just got the println macro. Yeah. Alright, so, yep, got all this set up. Alright, first part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess. Let's get coding. So, the import syntax is use, and then IO, and yeah, so it uses the double colon style from C++. It uses the import statement. Alright, so inside our main, we'll println guess the number, and println input for guess, and let mute guess. Let mute, okay. Huh. String new IO standard in dot read line and mute guess. Okay. Expect failed line. Println You guess that. Yes. Ooh, so formatting is built into the standard print. Nice, nice. Nice typing particles. Yeah. I have kitted VS Code the fuck out. Yeah, I'm not sure if any of these, yeah, I'm using a few cool things, but yeah. Hey. So. Alright. Yeah, this code contains a lot of information. Let's go over it line by line. To obtain user input and then print the result as output, we need to bring the I/O library into scope. I/O comes from the standard library, which is the standard STD acronym. Yeah. Semicolon. There. Okay. So by default, Rust only brings a few types into the scope of every program in the prelude. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with the use statement. Using the standard I/O library provides you with a number of useful features, including the ability to accept user input. Alright, let's look at the prelude. Okay. Rust comes with a variety of things in its standard library. However, if you had to manually import every single thing that you use, it would be very verbose, but importing a lot of things that the program never uses isn't good either. A balance needs to be struck. Prelude is the list of things Rust automatically imports into every Rust program. Kept as small as possible and is focused on things, particularly traits, which are used in almost every single Rust program. Currently, there are other preludes you can use. But yeah, which you just import. But yeah. Prelude contents. First version of Prelude, Rust 2015 and Rust 2018 lives in standard Prelude 1. Standard Prelude Rust 2015 and standard Prelude Rust 2018 re-export this Prelude and re-exports the following. So, standard markers copy, send, size, sync, and unpin. Okay. Marker traits that indicate fundamental properties of types. Ops, drop, FN, FN mute, FN once, various operations for both constructors and overloading parentheses. Standard mem drop, convenience function for explicitly dropping a value. Standard box, a way to allocate values on the heap. Standard borrow to owned, conversion trait that defines to own, the generic method for creating an owned type from a borrowed type. Right, so clone, produce a copy of the value. Partial partial ord, and ord. Comparison traits, implement comparison operators. Then asref, smute, into and from, which are generic conversions. Default, types of default values. Then iterator, extend, into iterator, double-ended iterator, and exact size iterator. Okay. Then options, self-sum and none. Right. Result, self-okay, error. Type for functions that may succeed or fail. Then string and toString, heap allocated strings, and vec, a growable heap allocated vector. Okay. Then Prelude in Rust 2021 includes all of the above and also from try into and from iterator. Okay. Alright. So. Yep. As you saw in Chapter 1, the main function is the entry point into the program. There. The FN syntax declares a new function. Parentheses. The parentheses indicate there are no parameters, and the curly bracket starts the body of the function. As you also learned in Chapter 1, println bang is a macro that prints to the screen. Code is printing a prompt stating what the game is and requesting input from the user. Now, here's fun stuff. So, we've got let mute guess string new. This is a let statement which is used to create a variable. This line, so let apples equals 5, which just create a new variable named apples and binds it to the value of 5. In Rust, variables are immutable by default. That's an interesting thing. We'll be discussing this concept in detail in the variables in the ability section in Chapter 3. Following example shows how to use mute before variable name to make a variable mutable. Right? So comments are just double slash, got it. Yeah. Immutable by default variables is interesting. I guess I'm guessing the difference between mutable variable and a constant, that a constant cannot or a constant gets inlined and immutable variable like gets allocated just for stuff that can be mutated but blocked and reassigned. It makes sense for like what the language is trying to do. Yep. Introduce immutable variable named guess. On the other side of the equal sign, value guess is bound to. Yep. Bring new. Alright, so method calls are done with colon instead of like dot and other languages. Associated function, okay. Associated function, also probably known as like static methods or such. Yeah, different syntax for a method and a AF, which is neat. Alright. Did in the IO functionality from the standard library of standard IO on the first line of the program. Now we'll call the standard in function IO. Right, which probably just grabs us the standard in object. Yep, returns an instance of standard in, which is the type that represents handle to the standard input for your terminal. Then there's readline and mute guess. Close the readline method on standard in to get input from the user. We're also passing one argument into readline, which is mute guess. Job readline is to take whatever the user types into standard input and append that into a string without overwriting its contents. So it takes that string as an argument. The string argument needs to be mutable, so the method can change the string's context by adding the user input. And indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. Now, all you need to know is that like variables, references are immutable by default. Hence, you need to write in mute guess rather than and guess to make it mutable. Chapter 4 will explain references more thoroughly, okay? Yeah. Right, yeah, I know that, I've, like, done a bit of C before, so I know that, like, that, putting an AND would, give you, would pass in the pointer address, which you would then need to convert with a star on the other side. Still working on this line of code. They're now discussing a third line of text. It is still part of a single logical line of code, because semicolon hasn't been met yet. Up next is expect. Yep. Alright, it recommends you new line whenever you do a method call, okay? One long line is difficult to read, so it's best to divide it. Especially when I've barely got any, like this is the most room I get. Yeah. Read line puts what the user types into the string we're passing it, but it also returns a value. In this case, an IO result. Rust has a number of types named result in its standard library, a generic result as well as specific versions for submodules such as IO result. Result types are enums, which is fixed set of values. Those values are called the variants. We'll talk about this more later. For result, the variants are always OK and error. OK variant indicates operation was successful, and inside OK is the successfully generated value. Error means the operation failed, and error contains information about how or why the operation failed. The purpose of these result types is to encode error handling information. Values of the result type, like values of any type, have methods defined on them. An instance of IO result has an expect method you can call. If this instance of our result is an error, they'll expect will cause the program to crash and display the message that you passed as an argument to expect. The readline method returns an error. It would likely be the result of an error coming from the underlying OS. If this instance of our result is an OK value, expect will take the return value that OK is holding and return that value to you so you can use it. In this case, value is the number of bytes and what the user entered into the standard input. Okay. Don't call expect, the program will compile, but you'll get a warning. Wanna have that. You should handle your errors. Trust warns you that you haven't used the result value returned from read line, indicating that the program hasn't handled a possible error. Yeah. This is a cool thing about Rust. It is very, very good at its error handling. Its compiler is very nice. Rust warns that you have used result, indicating program hasn't handled possible error. The right way to suppress the warning is to actually write error handling, but because you want to crash the program when a program occurs, you can use expect. We'll learn about recovering from errors in Chapter 9. Printing values with println placeholders. Aside from the closing curly bracket, there's only one more line to discuss in the code added so far, which is formatting. Delicious. Think of curly brackets as little crab pincers that hold a value in place. You can print more than one value using curly brackets. First set of curly brackets holds the first value, second holds the second, and so on. Printing multiple values in one called println would look like this. Right? Yeah. Ferris pincers, yeah. I completely forgot. I should... For tonight's stream, I've got a special guest. Right. Ferris, yeah. Where are they? Up. And you can just, go over here, buddy. There. Yeah. I couldn't sleep last night, so I made this little LEMMA edit of Ferris. It looks so good. It looks so good. So cute. Ferris LEMMA, yeah. I might put that as as a BT emote at some point, but yeah. Okay. Testing the first part. Alright, so let's cargo run. Let's input a guess. Clemus. So let's 98. You guessed 98. Program ended. Yay. And I can also type or also -1 or 1. Cargo run. Good. There it is. Put in a crab emoji. You guessed crab. Okay. First point. Yeah, at this point, the first part of the game is done. We're getting input from the keyboard and then printing it. Next, we need to generate a secret number that the user will try to guess. Secret number should be different every time the game. Yeah, every time, so the game is fun to play more than once. Let's use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, there is an official RAND crate. let's head over to our cargo.toml. Alright. Remember, the crate is a collection of Rust source code files. Project we've been building is a binary crate, which is an executable. Brand crate is the library crate, which contains code intended to be used in other programs. Cargo's coordination of external crates is where Cargo really shines. Before we can write the code that uses rand, we need to modify cargo toml to include the rand crate as a dependency. Alright, so that will be rand equals 083. Oh, I guess that's, yeah. Semver, yeah, alright, yeah, so, dependencies, yep, that's where you put project, yeah, crates your project depends on which version of the crates you require. In this case, we'll specify rand with semver, okay, yep. Number 083 is shorthand for, this is one of my this is one of the things I knew about Rust and is one of my favorite things about it, where not having a version there will, or not having like a specific modifier will use the caret modifier by default instead of equals, which is very good. Yeah. Which, yeah, more things should act like that. Yeah. Alright. Now, let's build the project. Cargo. Build. Pull this up. Fetching! Yay! Did. Okay. And there. A lot of fetching, yeah. Right, yeah, so downloaded get random, downloaded PPV Lite, downloaded downloaded rand chatter, downloaded rand core, download 5 crates. Why? And this is how not invented here syndrome starts happening. Is if we go and look at depths, that gave us a lot of, like, that is 5 sub-dependencies that rand has. This makes me sad. You may see different version numbers, they'll all be compatible with the code thanks to semver. Different lines depending on the OS. Yeah. Yep. That's different things. Yeah. Now that we have an external dependency, Cargo fetches the latest versions of everything from the registry. Copy of data from crates.io. Crates.io is where people in Rust ecosystem post their episodes, Rust projects, or others to use. After updating the registry, Cargo checks depths and downloads any crates you don't have yet. In this case, although we only listed rand as a dependency, Cargo also grabbed other crates that rand depends on to work. Here in this case, it looks like it might be rand being split so you can actually grab a smaller portion. Yeah. libc is a C library shim. CFG if is macro help. I'm not sure about the others. Yeah. I didn't actually get libc CFG if. I got get random, PPV Lite 86, rand itself, rand chacha, and rand core. Yeah. Crates.io. How about, alright, so rand. Let me just take a look at this. So dependencies. The rand core is core random number generator traits and tools for impl. Right, yeah, then libc optional, log optional, textmd2, simd2, vectors, chacha random number generator, okay. Yeah. Oh, I did get CFGF. I just already had that downloaded. Okay, yeah. Alright, then, yeah, so rand core is just the core random number generator, okay. Yep. Core traits and error types of rand, plus tools for implementing RMGs. Yep. Okay. Rand chacha. Alright. Oh. Alright, yeah, so it does it does look like, what Rand, yeah. So it looks like what Rand does, yeah. Rand, yeah, worth pointing out what Rand is not. Small. Most low-level crates are small, but the higher-level Rand and Randister each contain a lot of functionality. Not simple impl-wise. We have a strong focus on correctness, speed, and flexibility, but not simplicity. Alright. It's not slow, okay, yeah. I think what is, yeah. Built over Rancor, yeah. Okay, yeah. It looks like, this is just, like, meant to be more usable and has multiple RNG algorithm backends, which I think is pretty cool. So yeah, that's acceptable, I think. Yeah, I'm fine with that. It's not NPM is even. For those who don't know, welcome to hell. This is even. This is a library that adds one function for Node.js. The isEven function returns true if the given number is even. This project gets 600,000 downloads a month. Searches even on Crates.io. Oh no. Or wait. That description is busted, yeah. Why? Okay. So... Why? Why? But, like, here's the difference. IsOdd here has gotten 1,102 downloads all time. isEven has gotten 271 downloads all time. isEven Node.js gets 600,000 per month. It depends on isOdd, which gets 1.5 million downloads a month. It depends on isNumber, a single function library. A single function library that gets 220 million downloads per month. Fuck you, Brendan Ike. Here's the worst thing. I can't even fault the existence of isNumber. Having multiple layers of dependency is way funnier than it existing in the first place. Yeah, exactly. Yeah, like, look, isNumber is sadly necessary in JavaScript, because JavaScript is the worst programming language ever made. God, I hate JavaScript. Look at this. Look, yeah. Like, there's no to be fair, type of nan should be number, but it should be, not usable. JavaScript is bad. You should not have a language with only floating point numbers. You should not... I'm not going to trail this stream to explain about how bad JavaScript is. Right? Is learning languages that are arguably good. I'm not going to derail it. Talk about languages that suck. Okay. Yeah, if y'all want to actually, one quick thing, I recommend watching two videos. two very, very good Destroy All software videos. Basically, the two I like the two Destroy All software talks that I think are worthwhile. Or actually, no, honestly, uh, all of Gary Bernhardt's talks are really interesting, but the two important ones are WAT and the birth and death of JavaScript. I think the birth and death of JavaScript is a genuinely, really, really interesting talk, and y'all should give it a look sometime. It is actually really cool. Like, it's just really interesting. Like, it's cool. Yeah. It's basically talking about, like, yeah, I need to resurrect my blog post on getting JavaScript, C++, C# interrupt with async, working with async op someday. Ooh, fun. I've seen WAP, but not the other one yet. The other one is like 40 minutes long. It takes a while, but if you like care about, like, if you're interested in like software and computer systems, I genuinely super rec you watch The Birth and Death of JS. It's really interesting, and it has actually like kind of predicted the future. Yeah, like it extrapolates from what was known about the JavaScript ecosystem at the time of 2014, and it's just really interesting. You should give it a look sometime. Actually, yeah. Ooh. Oh no. Yeah, I can look into that later, but yeah. Back to focusing. May see different version numbers, they'll all be compatible with the code thanks to SymVary, yep. After updating the registry, Cargo checks dependencies section and downloads any crates that you don't have yet. Yep. In this case, although we only listed rand, Cargo grabbed other crates that rand depends on to work, yep. Immediately, run build again without making any changes. You won't get any output aside from finished, because Cargo knows it's already downloaded and compiled the deps, and you haven't changed anything about them in your Cargo toml. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. Right? If you just make a change, then it'll just recompile that. But yeah, hooray for lazy recomp! Ensuring reproducible builds with cargo.lock, which is a very helpful and interesting thing. Yeah. Oh, thank you for lurking, Jasper. Great to have you here. Yeah, so, like, if get random, libc, flight 86, rand chacha, randcore, rand HC, and myself and Wazi, which I'm guessing is, the Wazi stuff. What is Wazi? See. Yep, Wasi. What is Wasi? Oh, WebAssembly System Interface, okay. Yeah, is this WebAssembly System Interface, yep. Modular System Interface to WASM, security and portability, okay, yeah. Yeah, just like, yeah, alright. Yeah, OS-like features including files and file systems, Berkeley sockets, clocks, and random numbers. Right, yeah. Isn't limited by the need to, yeah, independent of browsers, so it doesn't need to depend on web APIs or JS, and isn't limited by the need to be compatible with JS. Has integrated capability-based security, so it extends WASM's characteristics and bugs to include. Yeah, no, this is just. Gary Bernhardt predicted the fucking future. Jesus Christ, my guy. Yeah. Stop getting sidetracked by WebAssembly. Yeah. Reproducible builds with cargo lock, yep. What happens if next week version 084 RAND comes out and that contains an important bug fix, but also contains a regression that'll break your code? That's cargo lock, okay, so yeah. Updating a crate, you can just run cargo update to update all your crates. Yeah. There's one thing I want to I do like a dash S. But yeah, can you like yeah, is there a way to cargo rusty? Okay. I'm just interested. Alright, yeah. Alright, where? Where does that go? Just rusty. Yes, then, where does that go? In like, really? But did that work or no? Now I wanna, like, I would really like, I'm very interested in actually, like, see, yeah. Target, depot, depth, but did it actually, yes, it did. I want to see this. Like, I'm just really interested in seeing what this looks like. But yeah, so, yeah. Yep. Oh, these are some delightful names. Okay. Yeah. That's a lot of assembly, actually. Probably because there's prelude and everything. Also, this is like this non-optimized, yeah. Yeah. This is a lot of stuff. Wow, yeah, that is a lot of assembly, huh? Wee. Yeah. Mostly the panic handling infrastructure and a bunch of implicitly generated drop functions. Yep. Not surprised. Yeah. If you wanted to use Rent 090 or any version of 09X, you'd have to update cargo commel. Yep, then run build. Yep, cargo and its ecosystem we'll discuss in 2014. Alright, anyway, let's generate a random number. So, 2. And R and C. And let's print number rand red RNG and range 1.101. There. Right. That's, yeah. The 1.101 syntax is like, for now, we'll, like, print the println secret number is bit number. There. Now, yep. Yeah, RNG trait defines methods that random number generators implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail, okay? Yep. Adding 2 lines in the middle, rand thread RNG function will give us a particular random number generator we're going to use, one local to the current thread of execution and seeded by the OS. Then we'll call genRange. Yeah, method defined by RNG, trait the run scope using rand RNG. Yep. Takes a range expression, yeah. Inclusive lower, exclusive upper, makes sense. Instructions for using a creator in each traits documentation. You can just do cargo doc -- open. So cargo doc open. Oh. Why the fuck did you open an atom? Ah. Oh well. I'll figure. It's probably like just default like handling or whatever. I really wish there was like some way to make it so HTML files only open in like a text editor sometimes and only open in a browser sometimes without having to like manually pick them every time. But yeah. Second line, you added code prints the secret number, yep. Then now if we do cargo run, cargo run. Yeah, it's getting different numbers every time, yay. Oh, hi, Ferris. Comparing the guess to the secret number. And now that we have user input and a random number, we can compare them. Step shown in listing 2.4. Note this code won't compile quite yet. That's what Ferris is here to warn us about. Alright. So. Guess. And. Grid number. Ordering left is propellant. All ordering. Oh, capital L left. Greater. Oh, commas, not. Ordering will println to win. Right, yeah. And we'll want yeah, I should probably alphabetize these. Use standard ordering. Oh, double. Okay, yeah. This won't work because, yeah, that no method construct string found in the current scope. Yep, because guess is a string. That's not okay. Yep. So, oh, it's CMP, not CLMP. Yep, and now that's angry because expected struct string found in. Right, so yeah. Turns variant of ordering enum, which we brought in here. Then, yeah. So users gets 15, we randomly generated 38, yep. So ordering greater, yep. Yeah, this is just like your less, greater, equal stuff. This will be angry. Now, here's where we get one of the coolest things of Rust. So let's cargo run, and it'll shout at us. Angry. For more information about this error, let's say Rust C -- explain EO308. This kicks ass. Genuinely one of the coolest things in Rust is that when you are when you do something wrong and there's a compiler error, it will tell you in detail what's up and how to fix it. Yeah. This error occurs when an expression was used in a place where the compiler expected an expression of a different type. It can occur in several cases, the most common being when calling a function and passing an argument which has a different type than matching type in the function deck. Yeah. It is the most user-friendly, compiler I have ever seen. All languages should have this good, this friendly of a compiler. Of, just saying, hey, here's what's wrong, here's common cases this can pop up in, here's how to fix it. That should be a universal thing, because user-friendliness is just so important. Also doesn't output 300 lines errors free from the simplest thing like C++, yeah. If there's nothing else that you like from Rust, this is something that all programming languages should take notes on. It takes a lot of effort to get that to get it to work like this, but oh, is it worth it? Yeah, true. I've only gotten at most one page of errors, maybe two. Yeah, exactly. It is just so user-friendly. It's just wow, it's good. Oh wow, we're only 1 hour in so far. Interesting. Oh, I love Adderall. It's so much. Hey. Yeah. Yeah. Mismatched types. Strong and static type system. It also has both. Yeah, strong and static type system with inference. Ah, thank God for inference. Love inference. Yeah. Alright, so yeah. We wrote let me guess equals string new. Rust was able to infer that guess should be a string and didn't make us write the type. Secret number, on the other hand, is a number type. Few number types can have a value between 1 and 100. I32, a 32-bit number, U32, an unsigned 32-bit number, I64, a 64-bit number, as well as others. Rust defaults to I32, which is type secret number, unless you add type info elsewhere that would cause Rust to infer a different numerical type. The reason for the error is that no matter what type of number you got, you can't compare a string and a number. So, we gotta figure out how to do that. So, yeah. So, yeah. Is this legal? Ooh, shadowing, okay. Alright, yeah. Alright, so there's shadowing, okay. Let guess guess 32 equals guess trim parse expect number. Right. We should be happy. Combine guess to the expression guess trim parse. Guess in the expression refers to the original guess that was a string with the input in it. Trim on string instance will eliminate any white space at the beginning and the end. Although U32 can contain only numerical characters, the user must press enter to satisfy read line. When the user presses enter, a new line character is added. Yep. So it'd be 5 back in, yep. yeah, we've got a trim. Yeah, so trim eliminates n or rn, then parse that. Right, yep. Because this method can parse a variety of number types, we need to tell us the exact number type we want by using let guess your 32. Yay, type annotation. Built-in number types, yep. Theoretically, you could just use, like, U8 or whatever, but yeah. 232 works. Yep. Call to parse could easily cause an error if, for example, string contained thumbs up, then a thumbs up, then no way to convert that to a number because it might fail. Parse returns result type, much as the readline method does. Treat this result in the same way by using the expect method again. Parse returns an error result variant because it couldn't create a number from the string. Expect will crash the game and print the message we give it. If parse can successfully convert the string to a number, it'll return okay. Expect return the number we want. Yep. So now, new player. Oh no, I did explain again, not cargo build. Cargo run. Alright, all good. 20. Yay! Woo! Even though spaces were added before the guess, the program still figured out the use of guess 76. Run the program a few times, yep. Yeah. 50. 80. Yay! That works! Now you can loop. Loop keyword creates an infinite loop. We'll add that now to give users more chances at guessing the number. Alright. So, that means... Alright, so... Loop. Up. Then I can... Up. Now, tap that in. Yay! Moved everything from loop into loop from the guess input prompt onward. Sure to indent the lines inside the loop, another force space each run program again. Okay. Alright, so 100 cubic. Oh, did I not save it? I did not save it. Okay, so big, small. You win, but it still wants us to guess. Now we could just that, but that's a crash. Yeah. Just type a number, parse int error. Yep. Alright, so yeah. You always interrupt the program by using keyboard shortcut Control C, or preparing the guess. User enters a non-number answer, program will crash. Yep. Typing quit actually quits the game, but so will any other non-number input. This is suboptimal. I want the game to automatically stop when the correct number is guessed. So, yay. Right, so instead of just a single statement, we're going to break it out. Up. Up. There. So now print you win and break. And break after you win makes the program exit the loop when the user guesses the secret number correctly. Exiting the loop also means exiting the program. The loop is the last part of main. Handling invalid input. Alright, so further refine the game's behavior rather than crashing the program when the user inputs a non-number. Let's make the game ignore a non-number so the user can continue guessing. Alright, so instead of doing an expect, we're going to match. So, guess U32 match, guess trim parse, and get rid of that. Alright, so okay, num to num, then error underscore because we don't care to continue. Yeah. Can also can also just break this out into another, so we could print ln please number. Yeah. Use comma, yeah. Good, yeah. Alright. Switching from expect to match is one way moving from crashing to handling. Parse returns the result type and results in enum with OK or error, yep. Parse not able to turn the string into a number will return an error value, yep. Not match OK, so it'll go into the error. Alright. Cargo run. Gate 99 period grab. Yeah, and then 82, yeah. Win, yay! With one tiny final tweak, we'll finish the guessing game. Let's just get rid of that secret number print because that defeats the purpose. Yay! Alright. Cargo run. Tiling. Alright, so 50, too small. 60, small. 90, too big. 80, big. 70, small. 5, big. 70, 74. 3, 72. You win! Yay! Ah. Alright. Yay! That works. At this point, you've successfully built the guessing game. Congratulations! The project was a hands-on way to let you to introduce you to many new Rust concepts, let match, functions, external traits, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax, and Chapter 6 explains how enums work. Alright? Onward! Common programming concepts, okay. We got keyword. Alright, so let's keep in mind all these keywords. As for casting, async and await are their usual. Break is usual. Const is inline to continue usual. Great! Okay. That's a link to an external crate or a macro variable representing the crate in which the macro is defined, okay. Dynamic dispatch to a trade object, okay. Else, fallback, else is usual. Enum is usual. External link to an external crate function or variable. False, fn, function pointer type. For, if, implement inherent trait function. Inherent or trait functionality. In part of, for loop syntax. Woo! Alright, so. Yep. So it's got like advanced fors, for in, Let is find variable. Loop is always loop. Instead of just a while true or whatever. Match, mod for module. Move, make your closer take ownership of all its captures. Ooh. Mute, denote mutability, okay. Pub for public. Ref, bind by reference. Return from function. Capital S self type alias for the type we're defining or implementing. Lowercase self method subject or current module. Static, Alright, global variable or lifetime lasting the entire program execution, okay. Structs, super, traits, kind of trait. Boolean true, type alias or associated type. Type union. Only a keyword when used in a union deck. Unsafe, the crime zone. And where denote clauses that constrain a type, and while, alright, For future use, things that could be a thing are abstract become box, do, final, macro, override, priv, try, type of, Unsized, virtual, and yield. Oh, is there no type of? How do you... Yeah, is there like a way to get type? Yeah. Raw identifiers, okay. Yeah. Yep. So raw or syntax that lets you use keywords where they wouldn't normally be allowed, okay. Matches keyword. Try to compile the following matches its name. You can't do that. But you can do our hash match. Okay. Yeah. Raw identifiers allow you to use any word you choose as an identifier, even if that word happens to be served. Raw IDs allow you to use libraries written in a different Rust edition than your crate. For example, try isn't a keyword in 2015, but it is in 2018. If you dep on a library that's written in 2015 and has try, you'll need to use raw identifier rhash try. Yep. Call that function from your 2018. Okay. Interesting. Yeah, that's appendix F. Okay. Got it. Storing variables with values. Okay, by default, variables are immutable. One of many nudges Rust gives you to write your code in a way that takes advantage of safety and easy concurrency that Rust offers. However, you still have the option to make your variables immutable. Yeah, technically yield are already being used, but under very unstable features. Yeah, hello, Grey Jack. Good to meet you. Yeah, no. Yeah. I'm not surprised that, like, some of those are already being, like, used in, like, nightlies, but yeah. Alright. Alright, I'm just gonna keep using this one directions, or no, one cargo, whatever, words. I can't talk, yay, so, I'm just gonna, make a new, or no, you're gonna first rename main.rs, main-guessing.rs. Hopefully that won't link or anything. Yes. Main.rs. Alright, so main. Let x equals 5. Println. Yep. So this is about mutability stuff. So value of x is x equals 6. This is a crime. Println. The value of x is x. Yep. Yeah, this is illegal. Alright. Yep. Yeah. Not assigned twice to immutable variables. Yep. Example shows how the compiler helps you find errors in your programs. Yeah. I love Rusty Explain. I think, I like how user-friendly Rust is. Like, I think that's a really good thing. Like, I wish that, other, compiled language, I wish other, even, interpreted languages were this user-friendly. Yeah. Neurodivergent. Yeah. Hello, VTuber Weaver Simper. Good to meet you. Yeah. Okay, so simple shows how the compiler helps you find errors in your programs, even though compilers can be frustrating. They only mean your program isn't safely doing what you want it to do yet. They do not mean that you're not a good programmer. Yep. This makes me, there's definite, I already know, there are a few things that are just not great with Rust, oh wait, I didn't even put a semicolon there. Yeah, the help add semicolon here, it knows where you want to put the semicolon and stuff, yeah. Can I learn anything from this stream if I'm a complete dumbass? Yeah, probably. Yeah. I have gotten a bit, far into, yeah, into like learning Rust. So you might want to like start from like the you might want to start from the start of the book if you want to learn Rust. Yeah, I'm going through and learning it at the same time as everyone else watching. So yeah. Yeah, Rust is a cool programming language. It's got a lot of interesting ideas in it, and like, even if I don't end up using it much, I still want to like, I want to learn how to use it myself so that I can, like, use that info to do, like, make my own languages and such, because making your own programming languages is fun as hell, honestly. Yeah. Important that we get compile time errors when we attempt to change a value that we previously designated as immutable, because this very situation can lead to bugs. One part of our code operates on the assumption that a value will never change, and another part of our code changes that. That's not good! Possible first part of code won't do it. It was designed to do. Yep. It can be difficult to track down after the fact, which is why it checks, during compile. In Rust, the compiler guarantees that when you say a value won't change, it really won't change. That means when you're reading and writing code, you don't have to keep track of how and where a value might change. Your code is thus easier to reason through. Mutability can be very useful. Variables are immutable only by default. As you did in Chapter 2, you can make them mutable by adding a mute in front of them variable name. In addition to allowing this value to change, mute conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable's value. And now if I let mute... Okay. Yeah, no, like, just... Here's another great thing with, like, for example, the VS Code integration for us. So, like, it'll tell you where it's wrong, and then it'll give you this blue underline to suggest how to fix it. That's really cool, yeah. I have a theme package that tries to support a lot of semantic highlight. Yeah, it's really good. There's just... I like when programming languages are good. That is very nice. Yeah. Allowed to change the value of the X binds from 5 to 6. Yep. So now this is legal. Cargo run. Yep. Now it's allowed. And using larger data structures, mutating an instance in place may be faster than copying and returning newly allocated instances. Smaller data structures, creating new instances and writing in a more functional programming style may be easier to think through. Slower performance might be a worthwhile penalty for gaining that clarity. Yeah. Yeah, like, I think, like, this is genuinely one of the best, like, explanations on, like, this is one of the best programming language tutorials I've seen before, too, because it really, like, it's explaining why things are the way they are and, like, how they can help, which is awesome. One of my other favorite programming language tutorials of all time is another good one. 4.0 Python. Python for asshat. Computers do a lot of shit. You're using a computer to do shit right now, so why not to learn how to make computers do shit yourself with my guide, Python for Asshats? Well, come on now, it's that or the Ask.NET book that you've been using as a paperweight. This is not a complete Python tutorial, but, like, for, like, the very, very basics of, like, it and kind of how programming languages work, it's definitely good. Yeah. Being unable to change the value of a variable might have reminded you of another programming concept that most other languages have: constants. Like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. Yeah. Constants are, very important, so, yeah, constants are designed to be inlined. So, we're about to cover types and typed annotations and data types, so don't worry about the details right now, just know you must always annotate the type of a constant because of the inlining. Data They can be declared in any scope, including global, which makes them useful for values that many parts of code need to know about. Constants may be set only to a constant expression, not the result of a value that could only be computed at runtime. Yeah, that means no function calls, just like mathematical expressions. Yep. Right. Use example of constant dec where its constant name is 3 hours and seconds, and its value is set to the result of multiplying 60, the number of seconds in a minute, by 60, the number of minutes in an hour, by 3, the number of hours you want to count. Yeah, one of the other cool things with the Rust book is that, like, you can run all these examples here to see what they're meant to do. So yeah. Rust is a cool language. I'd really like to, like, make a full language, programming language sometime, TBH. I think it'd be neat. Huh. I've got some interesting ideas for, like, SOLangs and such. Yeah. Rust naming convention for constants is to use all uppercase with underscores between words. Compiler's able to evaluate a limited set of operations at compile time with, lets us choose to write this value out in a way that easier to understand and verify rather than setting this constant to 10,800. Yeah. Or what that would look like. Yeah. Yeah, following expressions are constant expressions, so long as any operands are also constant expressions and do not cause any drop calls to be run. So literal values, which is just like raw values. Constant parameters. Yeah. Yeah, which are like just type bar stuff. Paths to functions and constants. Recursively defining constants is not allowed. Like a path is just like one of these. Paths to statics, only allowed within the initializer of a static. Tuples, arrays, structs, block expressions including unsafe blocks. Let statements and thus irrefutable, or block expressions including unsafe, yeah. Let statements and thus irrefutable patterns including mutable bindings. Assignment expressions, compound assignment expressions and expressions statements. Field expressions, index expressions, array indexing or slice with a U size. Range expressions, closures which don't capture variables from the environment. Built-in negation, arithmetic, logical comparison, or lazy Boolean ops. Shared borrows, except if applied to a type with interior mutability. Basically means that you can tamper with the insides of it. Deref operator except for raw pointers. Deref is going to be star. Yep. Then grouped expressions, cast expressions except pointers to address cast, function pointers to address cast, and unsizing cast all trade objects. Calls of const functions and const methods. Loop, while, and while let expressions, and if let, and match expressions. Basically, anything that can be determined at compile time and doesn't have to worry about, like, variables or user input or whatever. Yeah. Alright. They're valid for the entire time a program runs within the scope they were declared in. Makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn or the speed of light. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value to future maintainers of the code. Also helps to have only one place in your code you would need to change if hard-coded value needed to be updated in the future. Yeah, like just... I'm surprised it's not actually talking about inlining. What constants usually do for stuff like that is, if you have a constant, instead of, like, referencing a variable or memory address, during compilation time, it will just replace all places, it'll replace all instances of the constant name, like, that you treat like a variable access with, like, just the raw value of the constant. I want to say the reference talks about inlining in section of the constant static. Yeah, probably in the reference, but this is like the tutorial book. Might be a bit more confusing. Yeah. Now what you can do is shadow. You can declare a new variable with the same name as a previous variable. Condition says the first variable is shadowed by the second. The second variable is about what the program sees when the variable is used. You can shadow a variable by letting the same var's name and using the same var's name, repeating use of the let keyword as follows. So yeah, instead of doing let mute here, you could also let x equals 6. Yep. Yeah, for this one, it's saying let x equals x plus 1, then let x equals x times 2, and that'll only happen inside this block. Yeah, let's just write that out here. So yeah, that, then let x equals x plus 1, then a block, let x equals x plus 2, and just put the print there. Semicolon. Yep. X equals x. Yep, so x equals here, x equals here. It will never print out 5 because we shadowed that, but yeah. Shadowing is different from marking a variable as mute because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been completed. Other difference between mute and shadowing is because we're effectively creating a new variable when we use let, you can change the type but reuse the same name, which is cool. Yeah. So yeah, then you can do basically len there, yep, for example. Constructs allowed first space of variable is the string type, second space variable, which is a brand new happens to have the same name as the first one. It's a number type. Yeah. Shadowing thus spares us from having to come up with different names, such as spaces stir and spaces num. Instead, we can use the simpler space name. If we try to use mute for this, as shown there, we'll get compile time. So yeah. Yep. Now we've explored how variables work, let's look at more data types they can have. Yeah. Things to note with this one, just from my experience. Yeah. Yeah, from my experience, like, what this means is that you will be allocating a new variable, but like that'll just, yeah, but that's usually stacked, so it's not super critical. Yeah. Let's look at more data types. Every value in Rust is of a certain data type, which tells Rust what kind of data is being specified, so it knows how to work with that data. We'll look at two data type subsets, scalar and compound. Keep in mind, Rust is a statically typed language. It means that it must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it. In cases where many types are possible, such as when we converted a string into a numeric type using parse, we must add a type annotation like this. So like this means we gotta say exactly what it is. Yep. If we don't add that, it'll complain and it'll complain and say that we need to like give a type. Yeah. These errors are so good. I want to make, like, there should be like a framework for like friendly playing. Now I'm gonna look into like just, that'd be a cool thing to make sometime, is just like a friendly compiler. Like a framework for friendly compilers. Yeah. Scalar types. Scalar type represents a single value. Rust has 4 primary scalar types, which are integers, floating point numbers, booleans, and characters. You may recognize these from other programming languages. Let's jump into how they work in Rust. Yeah, scalar type means it has one value associated with it. Yeah, great for making error messages that look like Rust. Yeah. Yeah. Yeah, right. So, let's look at integers. An integer is a number without a fractional component. So there's no dot there, it's an integer. Yep. So there's a few different types. There's, yeah, there's integer 8, which, yeah, there's I. Yeah, they'll all start with I or U. That means whether they're a signed integer and unsigned integer. They also know an unsigned integer as a whole number in, like, mathematics. Yeah. Uh, yeah. Yeah, so integers can go below 0, or, yeah, signed integers can go below 0, unsigned can't, so 8, 16, 32, 64, and 128-bit signed and unsigned ints. And then, the arch size, which is I size or U size, which is about, what, yeah, which is about what the bit width of the CPU you're compiling for is. Yep. Yep. Ah. I size and U size depend on the kind of computer your program's running on. 64 bits on 64-bit architecture and 32 bits on 32-bit architecture. You can write int literals in any of the forms shown in Table 3.2. Note that number literals that can be multiple numeric types allow a type suffix, such as 57U8, to designate the type. Number literals can also use underscores, a visual separator, which will just have the same value. Right. Yep, and then you've got various things. So you've got, like, yeah, so you've got decimal, which is standard. You've got hex, which is OX. Octal, which is OO. Yeah, binary, OB, and then byte. Yeah, a byte with, like, a, yeah, for a character. Yeah. Right. So how do you know which type of integer to use? If you're unsure, Rust defaults are generally good places to start. Integer types default to I32. Primary situation in which you'd use iSize or usize is when indexing some sort of collection. Yeah, and then there's integer overflow. Rust has some, what are Rust rules? Okay, when you're compiling in debug mode, Rust includes checks for integer overflow that cause your program to panic at runtime. Oh, it panics, huh? Rust uses the term panicking when the program exits with an error. We'll discuss panics in more depth. Chapter 9, okay. When you're compiling in release mode with release flag, Rust does not include checks for integer overflow that cause panics. If overflow occurs, Rust performs 2 complement overflow wrapping. Yeah. In short, values greater than the maximum value the type can hold wrap around to the minimum of the values the type can hold. Yeah. In the case of U8, 256 becomes 0, 257 becomes 1. Yeah. So on. Won't panic, but the variable will have a value that probably isn't what you were expecting it to have. Relying on integer overflows wrapping behavior is considered an error. To explicitly handle the possibility of overflow, you can use these families of methods that the standard library provides on primitive numeric types. Okay, so wrapping in all modes with the wrapping methods. Okay, so wrapping add. Turn none if there's overflow with the check method. Turn the value in a boolean indicating whether there's overflow with overflowing methods. And saturate at the value's minimum or maximum values with the saturating methods. Okay. Rust has 2 primitive types for floating point numbers, which are numbers with decimal points. Those are F32 and F64, so they're IEEE 754 single and double precision floats. Don't worry about how those work. Don't worry about it. Don't worry about it. Don't worry about it. Trust me. Don't worry about it. They're a mess. Rust supports the basic mathematical operations you'd expect for all of the number types: addition, subtraction, multiplication, division, and remainder. Remainder, aka modulo. So yeah. Integer, division, rounds down to the nearest integer. Yep. Yeah. Alright, so rounding down for int division. Okay. always floor. Okay. So here's how you do that. So 5. Yeah, that's pretty basic. Yeah. Boolean types: true and false, 1 and 0. Pretty standard. Yep. Main way to use Boolean values is through conditionals. Then, lastly, cars. Yeah, cars or chars or whatever. Is 4. Oh! Rust cars are 4 bytes in size. Okay. Just represent a Unicode scalar, okay? Represent a lot more than just ASCII. For example, that cat right there. Yeah. Accented letters, Chinese, Japanese, Korean characters, emoji, and zero with spaces are all valid car values in Rust. Unicode scalar values range from U plus 00 to D7FF and D00 to 10FFFF inclusive. Character isn't really a concept in Unicode, so your human intuition for what a character may not match up with what a car is in Rust. What is 2 plus 800? What's that again? High surrogates. What are the surrogates? Is that PUA or? Reserved exclusive. Oh, they're reserved for UTF-16. Okay. It would be ambiguous and illegal for these individual code points to appear unencoded in UTF-16. Okay. Circuits are code points from 2 special ranges. Yep. Reserved for use as the leading and trailing values of paired code units in UTF-16. Unicode scalar values are code points minus the surrogates. Yeah. There are a couple other illegal ones, if I recall. That's like a newish thing. Yeah, I remember there was this a little while back. CVE 2021-42574. While the issue itself is not a flaw in Rust C, we're taking proactive measures to mitigate its impact on Rust developers. LTR and RTL characters. Whee! Yeah. Yeah, yeah, so Rust 150. Alright, so this is like just a weird attack. So yeah. Yeah, this is like a weird thing. Unicode has support for both left to right and right to left languages to aid writing left to right words inside left to right sentence. Also features invisible code points called bidirectional overrides. Yep, BDOs. Normally used across the internet to embed a word inside of a sentence of another language. It's reported to us they could be used to manipulate how source code is displayed in some editors and code review tools, leading to the reviewed code being different from the compiled code. Whee! Yeah. Following snippet with U plus NNNN, replace the Unicode code point NNNN. Yeah. Yeah. Yeah, so, a few of these are, yeah, so, mitigations, deny by default lints, protecting affected code points, effectively in string literals and comments. Lints will prevent source code files from being compiled, okay, yeah. If you're, yeah, so if you have legitimate uses, you should probably, just use the escape version. Codebase also includes non-Rust source code files. Periodically check following code points are not present. Yeah, so 2020A, 2020B, 2020C, 2020D, 2020E, 2066, 2067, 2068, and 2069 are illegal. Yeah. Also, homoglyphs are a turn, so yeah. Rust already includes mitigations, yep. Yeah. Not affected due to lack of support for non-ASCII identifiers in those resistant releases. Yeah. Yeah. programming is hard. Yeah. Compound types. Woo! Two primitive compounds. We got tuples, we got arrays. So, tuples a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, then cannot grow or shrink in size. This is an interesting thing. Yeah. There are a lot of languages I wish had tuples that don't. Like, imagine if the JVM had tuples, or like if Java had tuples. That'd be so good. Variable, yeah. Cut binds to the entire tuple, because tuple is considered a single compound element. To get the individual elements out of tuple, we can use pattern matching to destructure a tuple value. Yep. Yeah, let XYZ equals cut. Yeah, that's a pretty good way to do that, yeah. Is that actually a pattern match? That's interesting that that's a pattern match, actually. Yeah. Access tuple element directly using a period, so .0, .1, .2, and their name tuples we'll think about later, yeah. Tuple without any values, which empty paren is a special type that only has one value, also written empty paren. This type is called the unit type, and the value is called the unit value. Expressions implicitly return the unit value if they don't return any other value. Okay. And then arrays! Unlike a tuple, every element of an array must have the same type. Arrays in Rust are different from arrays in some other languages because arrays in Rust have a fixed length. Okay, fixed length arrays. Makes sense. Values going into an array are written as comma-separated list, gap, single type. Arrays are useful when you want your data allocated on the stack rather than the heap. Talk about that in chapter 4, okay? Or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as the vector type, though. Vector is a similar collection type provided by the standard lib that is allowed to grow or shrink in size, but that's heap. Unsure whether to use an array or vector, if you don't know, you should probably use a vector. Example when you might want to use an array is a program needs to know the names of the months of the year. Very unlikely such a program will need to add or remove months, so you can use an array because you know it will always contain the 12 element. 12 element? You would write an array's type using square brackets, and within the brackets include the type of each element, a semicolon, and then the number of elements in the array like so. So I32, so bracket, I32, semicolon, 5, close bracket. That's a good type sig, honestly. I like that type signature. Yep. Number 5 indicates the array contains 5 elements. Writing an array's type this way looks similar to an alternative syntax for initializing an array. Ooh. Alright. If you want to create an array that contains the same values for each element, you can specify the... Yeah. Happier. Hello, Alicia. Wonderful to see you. We learned new coding language? Yeah. I'm learning Rust, which is a pretty interesting and cool one, and yeah, changing what the game is coded in? Nah. I'm probably gonna keep using GDScript for most of it. I just want to learn this because I can. One thing that is possible, though, yeah, from what I know, it is actually possible to use Rust in Godot alongside the other stuff we've been using. Yeah. So let me, actually, Godot name Rust. Yep, Godot Rust. Yep. That's a thing. And it's pretty up to date, it looks, yeah. Yep. Yeah, this is, yep. Covers most of the exposed API of Godot 3.4. Nice. Yeah. Very cool. Yeah. Bindings do not support Godot 4 at the moment. Yeah, that's fine. But yeah, like, Godot Rust is something I could use and might use if the need arises, but for now, GDScript is good enough. Yeah. Yeah. Wrapper class, yeah. Yeah, I'll take a look at this at some point. Either way, yeah. Yeah, I'm not sure whether I'm actually going to use Rust much. It is an interesting language, but there's some good things and some bad things about it. Yeah. I just really like making sure I know plenty of programming languages so that if I need to write them, I can, and to just help me understand how computers work better. Yeah. Writing an array type this way looks similar to an alternative syntax for knitting an array. Yep. Array name. The array named A will contain 5 elements that will all be set to the value of 3. Right. So the same as writing let A equals 3, 3, 3, 3, 3, but in a more concise way. An array is a single chunk of memory of a known fixed size that can be allocated on the stack. Woo! Very helpful. You can access elements of array using indexing like this. Yeah, so first main RS, so A equals 1, 2, 3, 4, 5, then AO, A1, that's pretty standard. Variable name first will get the value 1 because that's the value to index 0 in the array. Variable name second will get the value 2 from index 1. Invalid array element access. Let's do some illegal shit. What's this? Alright, so this is a panic one, okay, so I could write this crime out, yeah. What happens if you try to access an element of array past the end of the array? They changed the example to the following, which uses code similar to the guessing game to get an array index from the user. Yeah. This code compiles successfully. If you run this code using cargo run and enter 0, 1, 2, 3, or 4, the program will print out the corresponding value at that index in the array. If you instead enter a number past the end of the array, such as 10, you'll see an output like this. Red main panicked at index out of bounds. The len is 5, but the index is 10. Yeah, run with Rust backtrace, envar to display backtrace. Hooray, backtraces! Yeah. Yeah. Runtime error, point of using an invalid value in the indexing operation. Program exited with an error message and didn't execute the final println. Yep. When you attempt to access an element using indexing, Rust will check that the index you've specified is less than the array length. If the index is greater than or equal to the length, Rust will panic. This check has to happen at runtime, especially in this case because the compiler has no idea what a user will type in. Yeah. This is an example of Rust memory safety principles in action. Many love languages, this kind of check is not done, and when you provide an incorrect index, invalid memory can be accessed. That's undefined behavior. Rust doesn't want undefined behavior. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. That's more in Chapter 9, okay. Functions! Functions are prevalent in Rust code. You've already seen one of the most important functions in the language, the main function, which is the entry point of many programs. You've also seen the fn keyword, which allows you to declare new functions. Rust uses snake case as the conventional style. Okay, so let's do this example while we're here. So, ln and hello world, then another function, println, and another function. Then we can another function, and if I cargo run, hello world and another function. They both run. Yay! Function defines function defs in Rust start with fn and have a set of parentheses after the function name. Curly brackets tell the compiler where the function body begins and ends. Oh, there is a run button. Alright, so I wonder if I hit like F5. Oh, I don't have a Rust debugger. Oh well. Doesn't matter right now. I can just deal with that later. For now, I can just use the well, yeah. Yeah. These don't have args yet. We'll find that out in a bit, probably. Yeah. Yep, got that. Function parameters! Woo! Here we go. So, now we're gonna do xi32, then the value of x and then we can just pass something. Woo! Let me. Sorry, my brain is not letting me form words right now. Nanamal Nariko, thank you very much for the follow. Welcome to the network. Am I not following you? Thank you very much. Yeah, I am now at 597 followers. I would really like it if I can get 3 more in the next hour or so before I have to wrap up. I won't, no pressure if I can't, but I think getting to 600 followers on Twitch by, right at the end of 2021 would be pretty cool. Right, value of x6 passes in, yay. Oh nice, yeah. Right, running the program usually gets the following output, yep. Check with another function as one parameter named x, type of x specified as i32. When 5 is passed to another function, the println macro puts 5 with a pair of curly brackets. We're in the format string, yay. In function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust design. Requiring type annotations in function defs means the compiler almost never needs you to use them elsewhere in code to figure out what type you mean, which is really cool. When you want a function to have multiple params, separate the param dex with commas. Yeah. Then label car. So the measurement is planning on doing a fun New Year's chat stream with some FF14, yeah. I am sadly not gonna be able to stream until midnight just because I've got plans with folks I live with. But yeah, yay, that works. Example creates a function named print labeled measurement with 2 parameters. First parameter is named value and is i32. Second is named unit label and is type car. Function then prints text containing both value and unit label. Woo! Run it. Yep, got that just fine. Because we called the function with 5 as value for value and h is the value for unit label, program output contains those values. Function bodies contain statements and expressions. Those are like the 2 fundamental units of programming. Statements are a instruction to perform an action, do not return a value. Expressions evaluate to a resulting value. Let's look at some examples. Creating a variable and assigning a value to it with the let keyword is a statement. In listing 3.1, let y equals 6 is a statement. Yep. Function defs are also statements. The entire preceding example is a statement in itself. Yeah, that means, statements do not return values. You can't assign a let statement to another variable as the following code tries to do. You'll get an error. That's illegal. When you run this program, it'll give you E0658. Yeah. Yeah, there's a few things here, so expression in this position are experimental, oh boy. Ooh, let me take a look at this. Tracking issue for ERFC 2497 if and while let chains. Okay. Ooh, been merged, so there are some places. Yeah, there are apparently some places. So if let and while let are legal, let is not. Okay. That's cool. Yeah. Yep. Fair declaration utilizes statements, yeah. Let-wise does not return a value, so there isn't anything for X to bind to. Yeah. Different from what happens in other languages such as C and Ruby, where the assignment returns the value of the assignment. You can write x equals y equals 6 and have both x and y equals value 6, not the case in Rust. Expressions evaluate to a value and make up most of the rest of the code you'll write. Consider a math operation, that's an expression. Function calls are expression, calling a macro is an expression. Block we use to create new scopes is an expression. Yeah. I want to see what this will do, actually. Let's go, let y equals, let x equals 3, x plus 1, print ln, value of y in y. What will that do, actually? Cargo run. Ah! Need a semicolon there, okay. I have an idea what. Value of y is 4, okay, so if you do not need a. Ah. Yeah, apparently that's just like an implicit, like, value return? Huh. Evaluates to 4, yeah. Var gets bound to y as part of the let statement, okay. X plus 1 line without a semicolon at the end. Unlike most of the lines you've far. Expressions do not need ending semicolons, okay. If you add a semicolon to the end of an expression, you return it into a statement, which will then not return a variable, okay. Makes sense. Keep this in mind, needs to explore function return values and expressions next. Functions with return values. Right, so 5, I32, 5. Right. Ooh, dead code warning, neat. Yeah, then, I can do 5 there. Yeah. That's neat. No function calls macros or even let statements in the 5 function, just the number 5 by itself. That's a perfectly valid function in Rust. No function's return type specified as I32. You can also return, right? Yeah. So like a single express. No. Did I hit F5? Finally, whoops. I did not mean to hit F5. I meant to just hit 5. Yeah. 5 and 5's functions return value, which is why the return type is I32, yep. So let x equals, yep, 5, yep. Those who are using the return value of function to initialize the variable. Because the function 5 returns 5, it's the same as just let x equals 5, yep. No parameters and defines the type of the return value, but body of a function is a lonely 5 with no semicolon because it's the expression whose value we want to return. Now, here's an interesting thing. If we do that, yeah. So, does that get inlined is the question. Any stations in chat know if this gets inlined? No pressure, but that does seem like a pretty good inline target. Might depend on, optimization and such. Running this code will print the value of x is 6. We place a semicolon at the end of the line containing x plus 1, changing it from an expression to a statement, and we'll get an error. Right? Yep. Because you need a tail or a return expression, okay? Mismatch types reveals core issue with this code. Definition of function +1 says return I32, but statements don't evaluate to a value. I do like the helps are so good. LEMMA, hello, Catton! Ah. Remember. What are the air sunglasses for? I'm celebrating because New Year's Eve. Woohoo! Yeah. Good. Yeah. Okay. So. Right. Comments. Idiomatic comment styles. Starts a comment with 2 slashes and the comment continues to underline. Okay. Yep. Yeah. Well, yep, you can put them on separate lines. Documentation comments. Do you slash star? Yeah, you can slash star, okay. I think that might be a dot comment. Yeah. Cross comment. Just checking. Yep, alright, so you got block comments. Yep. The line comments, block comments, inner line docs, inner block docs, outer line docs, outer block docs. Okay, yeah. I think triple slashes dot comment, yeah. Well, there's more, yeah. So you can do like inline, inner block docs. Yeah. Neat. Alright. Onward. Control flow. Yeah. Here's your standard if else or whatever. So if number less than 5, yep. You do not need parentheses are not mandatory. As long as it's got an expression there. That's interesting. Okay. Blossom. Hello, Blossom. I can't read any of this at all because I don't speak computer. That's okay. Yeah. I am learning how to speak computer. Yeah. Computer complains if you put parentheses anyway, yeah. Numbers. Oh, yeah. If number, yeah, that's illegal because gotta be a Boolean. New Year approaches, let's kick 2022's ass. Hell yeah, Nikki, great to see you, babe. You write a poem while I was drunk. Ooh. Error indicates Rust expected a bool got an integer. Unlike languages such as Ruby and JS, Rust will not automatically try to convert non-Boolean types to a Boolean. Fuck yeah. Quote me, I'm hungry. Yeah. I want some pizza, it's not midnight, I am. Yeah. You must be explicit and always provide if with a Boolean. You want the if code block to run only when a number's not equal to 0. Just put not equal 0 there. Yeah. I'm happy with that. Handling multiple conditions with elif. Yep, or else if, yeah. Yeah, else if is pretty standard. 4 possible paths you can take. Yep. If and let statement. Yeah, so. Ooh, so that's how you do ternaries. Okay. Yeah, so if condition. Alright, yeah, gotta have curly brackets. Yeah. Oh, yeah, that's. This is great, yeah. Wish Java let you do this, yeah. Yeah, Rust is a neat language. Yeah, no, if condition, yeah. I'm fine with that ternary syntax, yeah. Yeah, that's a good ternary syntax. Blocks code evaluate to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. Yep, means values have potential to be results from each arm of the if. Listing 3-2, results of both if arm of the else arm were I32. types are mismatched in the following example, you'll get an error because they've got to be the same. Yeah, oh boy, Ansker. There's some fun stuff with that. Expression on the if block evaluates to an integer and expression in the else block evaluates to a string. Yeah, so if this will work, variables must have a single type, and you have to know that at compile time. Repetition with loop. Often useful to execute a block of code multiple times. Yep, and more than once. So there's loop, which is just forever, or until break. There's while, and there's for. Alright? Yeah, that'll just run forever. And just hit like Control-C. Yeah. May or may not see the word again printed after Control-C depending on where the code was in the loop when it was interrupt. Press provides a way to break out of the loop from code, which is break. There's also continue to skip a loop, rest of an iteration. Yep. And ooh, labels. So alright. Alright, so that's interesting. Is that lifetime stuff? Is that apostrophe lifetime stuff? I know apostrophes have something to do with lifetimes. Alright, so, yep, counting up 0 to 2. That is the... Right. I'm glad you can, like, label loops and such. That would be cool. Right. Yep. Right. Returning values from loops. Break count. Okay, so you can break counter stuff. Alright, so you can break to return. Yeah, a break expression does take a return value. Okay, that's cool. That's cool. Like, yeah, like additional loops. Alright, yeah, then there's while. Construct eliminates a lot of nesting, and then there's looping through a collection with for. Could do this. Then, alright, so it looks like you only have 4 in with this? That's interesting. Approach error prone, we could panic index value test condition correct, yep. Also slow, because runtime code to perform conditional check whether index is in bounds. Yeah. 4 in A. Yes, that's, yeah, 4 ins are good. Safety and conciseness, for loops makes them most commonly. There's loop, yep. Yeah. Most stations would use a for loop. Way to do that would be to use a range, okay, which is type provided by standard libraries. Yeah, you've got, like, for lion range. You can reverse it, okay. Yep, that's range, yep. Alright, this is a sizable chapter. You learned about variables, scalar and compound data types, functions, comments, if expressions, and loops. If you want to practice with concepts discussed in the chapter, try building programs to do the following. So, convert temperatures between Fahrenheit and Celsius, generate the nth Fibonacci number, print the lyrics to 12 Days of Christmas, taking advantage of the repetition of the song, yeah. Okay. Yeah, this is like stuff that is pretty standard. So, let's get to the weird shit. It's time to learn about ownership. Ownership is Rust's most unique feature, and it enables Rust to make memory safety guarantees without needing a garbage collector. Therefore, it's important to understand how ownership works in Rust. In this chapter, we'll talk about ownership as well as several related features, borrowing, slices, and how Rust lays data out in memory. Rust Central features ownership. Although the feature is straightforward to explain, it has deep implications for the rest of the language. All programs have to manage the way they use a computer's memory while running. Some languages have garbage collection that constantly looks for no longer used memory as the program runs. In other cases, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks at compile time. None of the ownership features slow down your program while it's running. Because ownership is a new concept for many programmers, it does take some time to get used to. The good news is that the more experienced you become with Rust and the rules of the ownership system, the more you'll be able to naturally develop code that is safe and efficient. Keep at it. When you understand ownership, you'll have a solid foundation for understanding the features that make Rust unique. In this chapter, you'll learn ownership by working through some examples that focus on a very common data structure, strings. Alright, let's talk about the stack and the heap. In many programming languages, you don't have to think about the stack and the heap very often, but in a systems language like Rust, whether a value is on the stack or the heap has more of an effect on how the language behaves and why you have to make certain decisions. Parts of ownership will be described in relation to the stack and the heap, so here's a brief explanation. Both the stack and the heap are parts of memory that are available to code to use at runtime, but they're structured in different ways. The stack stores values in the order it gets them and removes them values in opposite order. It's last in, first out, or first and last out, or whatever. Philo, LIFO, lo-fi. Yeah, think of a stack of plates. When you have more plates, put them on top. When you need a plate, you take one off the top. Adding or removing plates from the middle or the bottom wouldn't work as well. Adding data is called pushing, and removing data is called popping. All data overflowed, or all data stored on the stack must have a known fixed size. Data with an unknown size at compile time or size that might change must be stored on the heap instead. The heap is less organized. When you put data on the heap, you request a certain amount of space. The memory allocator finds an empty spot in the heap that's big enough, marks it as being in use, and returns a pointer, which is the address of that location. This process is called allocating on the heap, and is sometimes abbreviated as just allocating. This is what malloc does. Pushing values onto the stack is not considered allocating, because a pointer is a known fixed size, you can store the pointer on the stack, but when you want the actual data, you gotta follow the pointer. Think of it as being seated at a restaurant. When you enter, you state the number of people in your group, and the staff finds an empty table that fits everyone and leads you there. If someone in your group comes late, they can ask where you've been seated to find you. Pushing to the stack is faster than allocating on the heap, because the allocator never has to search for a place to store new data. The location is always at the top of the stack. Comparatively, allocating space on the heap requires more work, because the allocator must first find a big enough space to hold the data, and then perform bookkeeping to prepare for the next allocation. Accessing data in the heap is slower than accessing data on the stack, because you have to follow a pointer to get there. Contemporary processors are faster if they jump around less in memory. Continuing the analogy, consider a server at a restaurant taking orders from many tables. Most efficient to get all the orders at one table before moving on to the next. Taking an order from A, then B, then A again, then B again would be way slower. Gotta run back and forth. The processor can do its job better if it works on data that's close to other data as it's on the stack rather than farther away as it keeps on the heap. Allocating a large amount of space on the heap can also take time. When your code calls a function, the values passed into the function, including potentially pointers to data on the heap, and the function's local variables get pushed onto the stack. When the function's over, those values get popped off. Keeping track of what parts of code are using what data on the heap, minimizing the amount of duped data on the heap, and cleaning up unused data on the heap so you don't run out of space are all problems that ownership addresses. Once you understand ownership, you don't need to think about the stack and the heap very often, but knowing that managing heap data is why ownership exists can help explain why it works the way it does. Alright, let's take a look at the rules. Each value in Rust has a variable that's called its owner. There can only be one owner at a time, and when the owner goes out of scope, the value will be dropped. We've walked through an example of Rust program already in Chapter 2. Now that we're past basic syntax, we won't include all the fun main code and examples. But if you're following along, you'll have to put the following examples inside a main function yourself. As a result, our examples will be a bit more concise, letting us focus on actual details rather than boilerplate code. Figure this out so we can get working on that. As a first example of ownership, we'll look at the scope of some variables. The scope is the range within a program for which an item is valid. Let's say we have a variable that looks like this. Hello. Variable s refers to a string literal, where the value of the string is hard-coded into the text of our program. The variable is valid from the point at which it's declared until the end of the current scope. Listing 4.1 has comments annotating where the variable s is valid. Alright? Yeah. Scope is defined by curly brackets most of the time. In other words, there are two important points in time here. When s comes into scope, it's valid, and it remains valid until it goes out of scope. At this point, the relationship between scopes and when variables are valid is similar to that in other languages. Now we'll build on top of this understanding by introducing the capital S string type. To illustrate the rules of ownership, we need a data type that's more complex than the ones we covered in the data type section of Chapter 3. Types covered previously are all unknown size, can be stored on the stack and popped off the stack when their scope is over, and can be quickly and trivially copied to make a new independent instance if another part of code needs to use the same value in a different scope. But we want to look at data that's stored on the heap and explore how Rust knows when to clean up that data. We'll use string as the example here and concentrate on the parts of string that relate to ownership. These aspects also apply to other complex data types, whether they're provided by the standard lib or created by you. Discuss string in more depth in Chapter 8. Okay? We've already seen string literals, where string values hard-coded into our program. String literals are convenient, but they aren't suitable for every situation in which we may want to use text. One reason is that they're immutable. Another is that not every string value can be known when we write our code. For example, what if we want to take the user input and store it? For these situations, Rust has a second string type, capital S string. This type manages the data allocated on the heap and as such is able to store an amount of text that is unknown to us at compile time. You can create a string from a string literal using the from function like so. That is a heap string. Double colons operators allows us to namespace this particular from under the string type, rather than using some sort of name like string from. I'll discuss this in method syntax in Chapter 5, and when we talk about namespacing with modules in Chapter 7. This kind of string can be mutated, so s.push roll print ln. They call them methods, yeah. Alright, yeah, you gotta let mute. Alright, now I can cargo run. Yep, and that does what's hello world. What's the difference here? Why can string be mutated but literals cannot? Difference is how these two types deal with memory. In the case of a string literal, we know the contents at compile time, so the text is hard-coded directly into the final executable. This is why string literals are fast and efficient. But these properties only come from the string literal's immutability. Unfortunately, we can't put a blob of memory into the binary for each piece of text whose size is unknown at compile time and whose size might change when running the program. With the string type, in order to support a mutable, growable piece of text, Yeah, we did that for a long time, yeah. Yeah, it causes problems. Yeah, it causes problems. With the string type, in order to support a mutable, growable piece of text, we need to allocate an amount of memory on the heap unknown at compile time to hold the contents. This means the memory must be requested from the allocator at runtime, and we need a way of returning this memory to the allocator when we're done. First part is done by us. When we call a string from, its implementation requests the memory it needs. Pretty universal in programming languages. However, the second part is different. In languages with a garbage collector, GC keeps track and cleans up memory that isn't being used anymore, and we don't need to think about it. Without a GC, it's our responsibility to identify when the memory is no longer being used, call code to explicitly return it, just as we did to request it. Doing this correctly has historically been a difficult programming problem. If we forget, we'll waste memory. Do it too early, we'll have an invalid variable. If we do it twice, that's a bug! We need to pair exactly one allocate with exactly one free at all times. Rest takes a different path. Memory is automatically returned once the variable that owns it goes out of scope. Here's a version of our scope example from listing 4.1 using a string instead of a string literal. Yeah, it's basically the same thing, so yeah. Natural point at which we can return the memory our string needs, the allocator, when S goes out of scope. When a var goes out of scope, Rust calls a special function for us. This function is called drop, and it's where the author of string can put the code and return the memory. Rust calls drop automatically at the closing curly bracket. This is this is interesting and fun. This does the destructor basically. There's some actual like really interesting stuff about standard mem drop. This is like honestly one of the coolest things that Rust does is there is no magic in standard mem drop. It disposes of a value by calling the argument's implementation of drop by using a closing curly bracket. Effectively does nothing for types which implement copy, which integers. Such values are copied and then moved into the function so the value persists. Yeah, this is like the coolest thing. Yeah, C++ did it too, yeah. Like, I like when there's, stuff that's not magic is really cool. Yeah. Yeah. Natural point at which we can return the memory our string needs to when S goes out of scope. In C++, this pattern of deallocating resources at the end of an item's lifetime is sometimes called resource acquisition is initialization, RAI. Yeah. Drop function in Rust will be familiar to you if you've used RAI patterns. This pattern has a profound impact on the way Rust code is written. It may seem simple right now, but the behavior of code can be unexpected in more complicated situations when we want to have multiple variables use the data we've allocated on the heap. Let's explore some of these situations now. Alright, so multiple variables can interact with the same data in different ways in Rust. Let's look at an example using an integer in listing 4.2. So we got let x equals 5, let y equals x. You can probably guess what this is doing. Bind value 5 to x, and make a copy of the value in x and bind it to y. We now have two variables, x and y, both equal 5. This is indeed what's happening because integers are a simple value with a known fixed size, and these two 5s are just pushed right onto the stack. Now, let's look at strings. Yeah. This looks very similar to the previous code, so we might assume that the way it works would be the same. It would make a copy of the value in S1 and bind it to S2, but that's not quite what happens. Take a look at figure 4.1 to see what's happening to string under the covers. String is made up of 3 parts shown on the left. A pointer to the memory that holds the contents of the string, a length, and a capacity. A group of data is stored on the stack. On the right is the memory on the heap that holds the contents. Yep, the length is how much memory, in bytes, the contents of the string is currently using. Capacity is the total amount of memory, in bytes, that the string has received from the allocator. And, yeah, the difference between length and capacity matters, but not this context, so it's fine to ignore it for now. When we assign S1 to S2, the string data is copied, meaning we copy the pointer, the length, and the capacity that are on the stack. We do not copy the heap data that the pointer refers to. In other words, the data representation in memory looks like figure 4.2. Yeah, they're basically just two pointers to the same place. The representation does not look like figure 4.3, which is what memory would look like if Rust instead deep copied the heap data, yeah. If Rust did this, the operation S2 equals S1 would be very expensive in terms of runtime performance if the data on the heap were big, yeah. C++ deep copies by default, yeah. Rust does not deep copy unless you, explicitly tell it to. Earlier we said that when a variable goes out of scope, Rust automatically calls the drop function and cleans up the heap memory for that variable. Figure 4.2 shows both data pointers pointing to the same location. This is a problem. When S2 and S1 go coming into the stream with low energy, this is beyond my brain, yeah. I'm managing right now, yeah. Good to see you, Chloe. When S2 and S1 go out of scope, they'll both try to free the same memory. This is known as a double free and is one of the memory safety bugs we mentioned previously. Freeing memory twice can lead to memory corruption, which can be security vulnerabilities. So, to ensure memory safety, there's one more detail to what happens in this situation in Rust. After let S2 equals S1, Rust considers S1 to no longer be valid. Therefore, Rust doesn't need to free anything when S1 goes out of scope. Check out what happens when you try to use S1 after S2 is created. It won't work, yeah. An error like this because Rust prevents you from using the invalidated reference. Okay. Where'd my train of thought go? Yeah. Did an error like this because Rust prevents you from using the invalid reference. This is illegal, you know. Yeah. I do like how it marks where everything happens, yeah. If you've heard the term shallow copy and deep copy while working with other langs, concept of copying the pointer length and capacity without copying the data probably sounds like making a shallow copy. But because Rust also invalidates the first variable, instead of being called a shallow copy, it's known as a move. In this example, we would say that S1 was moved into S2. So what actually happens is shown in figure 4.4. And that solves our problem. Only S2 valid. When it goes out of scope, it alone will free the memory and we're done. In addition, there's a design choice that's implied by this. Rust will never automatically create deep copies of your data. Yeah, therefore, any automatic copying can be assumed to be inexpensive in terms of runtime performance. Ways variables and data interact. Clone! If we do want to deep copy the heap data, not just stack data, we can use a common method called clone. Discuss method syntax in chapter 5, but because methods are a common feature in many programming languages, you've probably seen them before. Here's an example of clone. You could just do .clone, and it'll deep copy. When you see a call to clone, you know that some arbitrary code is being executed and that code may be expensive. It's a visual indicator that something different's going on. Stack-only data copy, another wrinkle we haven't talked about yet. This code using integers, part of which was shown in Lesson 4.2, works and is valid. This code seems to contradict what we just learned. We don't have to call we don't have to call to clone, but X is still valid and wasn't moved to Y. That's because they're stacked, so you don't need to clone. It's cheap, easy, no allocation, they're all good. So calling clone wouldn't do anything different. Just will shallow copy and leave it out. Rust has a special annotation called the copy trait that we can place on types like integers that are stored on the stack. If the type implements copy, an older variable is still usable after assignment. Rust won't let us annotate a type with the copy trait if the type or any of its parts has implemented drop. If the type needs something special to happen when the value goes out of scope, we add the copy annotation to that type. We have the copy annotation to that type, we'll get a compile time error. You'll learn about how to add the copy annotation to your type, the derivable traits in Appendix C. Not a big deal, okay. Yeah, Rust has a, yep. So what type implements the copy trait? You can check the documentation for the given type to be sure, but as a general rule, any group of simple scalar values can implement copy, and nothing that requires the allocation or is some form of resource can implement copy. There's some types that implement copy, so all int types, boolean, all floats, char, and tuples if they only contain types that also implement copy. Okay. Ownership and functions. Semantics for passing a variable to a function are similar to those for assigning a value to a variable. Passing a variable to a function will move for copy, just as assignment does. Listing 4.3 has an example of some annotations showing where variables go into and out of scope. So, right. So, S comes into scope here, moves into the function and is no longer valid. This, that's copy, so that's okay. So some string gets dropped there, okay. Try to use S after the call that takes ownership. Rust would throw a compile time error. These static checks protect us from mistakes. Writing code to main that uses S and X to see where you can use them, and ownership rules prevent you from doing so. So yeah, like just beyond here, S is illegal, X is just fine anywhere after. Yeah. Return values in scope. Returning values can also transfer ownership. 4.4 is an example with similar annotations to those in listing 4.3. Oh, thank you for the hydrate, Chloe. And a posture check. Right. Yeah. Right. So, yep. Gives ownership, string from, yep. Takes and gives back. Yeah, so takes and gives back, we'll just return it. Yeah. Ownership of a variable follows the same pattern every time. Assigning a value to another variable moves it. When a variable that includes data on the heap goes out of scope, it's validly cleaned up by drop unless the data has been moved to owned by another variable. Taking ownership and then returning ownership with every function is a bit tedious. What if we want to let a function use a value but not take ownership? It's quite annoying that anything we pass in also needs to be passed back if we want to use it again, in addition to any data resulting from the body of the function that we might want to return as well. Possible to return multiple values using a tuple is shown in list 4.5. This is too much ceremony and a lot of work for concepts that should be common. Luckily for us, we've got references! How much more is in chapter? Yeah, I think I'm gonna go until I've completed chapter 4 and then wrap up for the night. Because this is like the meat of Rust. Until we get to like, lifetimes. When are lifetimes actually? Lifetimes are all the way in chapter 9. Yeah. What are you gonna use Rust for? No idea! I just want to learn it for now. I have a couple ideas that I might want to use it for, but yeah. Issue with tuple code and 4.5 have to return the string to the calling function so we can still use the string after the call to calc length. Yummy borrowing, yep. String is moved to calc length. Here's how you define and use a calc length function that has a reference to an object as a parameter instead of taking ownership of the value. Yep, so yep. That's what you use the AND for. In other languages, yeah, and you'll use an AND there as well. Ampersands are references. In other low-level languages, they'll be referred, they'll be like the address of something. First notice, all tuple code and variable deck and function return values. Yeah. I'm gonna write out this one, so length S and string Q size S len. Right, then up here we can do that one string from hello. Oh, capital S here. Capital string, yep, thank you. Let len equals calculate 1 print ln of right, so this is legal. Yay! Notice all the tuple code and var deck and function return value is gone. Note we pass and s1 into calculate, and in its definition we take and string rather than string. Ampersands are references, and they allow you to refer to some value without taking ownership. Basically, it's just, it is the straight pointer for it. Opposite of referring, referencing by using and is dereferencing, which is accomplished with star, as it is in like other languages. See some uses of deref in Chapter 8 and discuss details of deref in Chapter 15. Alright, so function call here, yep. Yeah, and S1 lets us create a reference that refers to the value of S1, but does not own it. Because it doesn't own it, the value it points to will not be dropped when the reference stops being used. Likewise, the signature of the function uses AND to indicate that the type of parameter S is a reference. Let's add some explanatory annotations. Yep, S goes out of scope, but because it's borrowing, nothing happens. Yeah, scope, in which the variable S is valid, is the same as any function parameter scope, but we don't drop what the reference points to when S stops being used because we don't have ownership. When functions have references as parameters instead of the actual values, we won't need to return the values in order to give back ownership because we never had ownership. Call the action of creating a reference borrowing. As in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. You cannot modify a borrowed value unless you and mute it. Yeah, like, this is illegal. Yeah. But, yeah, we used and mute earlier, which is like that, yep. And you've got to put it on both sides. It's interesting that you have to put it on both sides all the time, just so, like, no matter whether it's your code or someone else, so, like, both your code and the code you're looking at both document it. That's good. Change S to be mute. Then we had to create a mutable reference with mute S, where we call the change function, and update the function's signature to accept a mutable reference string. This makes it very clear that the change function will mutate the value it borrows. Yeah. It means you can go here, you can borrow this, but you can't change it on the calling side. Yep. Yeah. Yeah. Change S to be mute. Yep. Then you can make multiple and mute. Yeah. Or, wait, no. You can only have one mutable reference to a particular piece of data at a time. Okay. Yeah, I can... That makes sense. Section preventing mutable references to the same data at the same time allows for mutation, but in a very controlled fashion. Something that newer stations struggle with because most languages mutate whenever you'd like. The benefit of having this restriction is that Rust can prevent data races. Yep. Which is a good thing to prevent. Yeah. Section preventing mutable references allows mutation. Yep. Data races. Two or more pointers access the same data at the same time. At least one of the pointers is being used to write the data. No mechanism being used to synchronize access to the data. Data races cause undefined behavior and can be difficult to diagnose and fix when you're trying to track them down at runtime. Rust prevents this problem from happening because it won't even compile code with data races. As always, we can use curly brackets to create a new scope allowing for multiple mutable references, just not simultaneous ones. Alright, makes sense. Similar rule exists for combining mutable and immutable refs. This code results in an error. I like the comments here. Right, yep. Look, R1 equals and S, no problem. R2 is and S, no problem. R3 and mu S, big problem! Yeah. We also cannot have a mutable reference while we have an immutable one. Users of an... yeah. Yep. Users of an immutable ref don't expect the values to suddenly change out from under them. However, multiple mutable references are okay because no one who's just reading the data has the ability to affect anyone else's reading of the data. Sense? Note that a reference's scope starts from where it's introduced and continues through the last time the reference is used. For instance, this code will compile because the last usage of the immutable refs. Println occurs before the mutable ref is introduced. Legal, yeah. Yeah, most Rust documentation and discussion will call with this chapter is calling immutable reference a shared reference instead, yeah. Scopes of shared references R1 and R2 end after the println were their last used, yeah. Yeah. Which is before the mutable ref R3 is created. These scopes don't overlap, so this code is allowed. The ability of the compiler to tell that a reference is no longer being used at a point before you end the scope is called non-lexical lifetime. Neat. And the barring errors may be frustrating at times. Remember that it's the Rust compiler pointing out a potential bug early, at compile time rather than at runtime, showing you exactly where the problem is. Then you won't have to track down why your data isn't what you thought it was. In languages with pointers, it's easy to erroneously create a dangling pointer, a pointer that references a location in memory that may have been given to someone else. By freeing some memory while preserving a pointer, to that memory. In Rust, by contrast, the compiler guarantees references will never be dangling. If you have a reference to some data, the compiler will ensure the data will not go out of scope before the reference to the data does. Let's try to create a dangling reference, which Rust will prevent with compile time error. Alright. So yeah, that means, yeah, expect named lifetime parameter. Oh, yeah, I am. Lifetimes are going to be interesting. Yeah. Discuss lifetimes in detail in Chapter 10. Disregard the parts about lifetimes. It does contain the key to why the code is a problem. This function's return type contains a borrowed value, but there's no value for it to be borrowed from. Yep, that's good. Yeah, new reference to a string here. S is a new string. And then reference, yeah, return a reference to S, but S gets dropped. Okay. Yep, it'll be deallocated, try to return a reference. That's no good. Alright. Yep, and then you can also just, you could just return S instead. Any given time can have either one mutable reference or any number of shared references. References must always be valid. Alright, and lastly, for tonight, slices. Yeah, that is, yeah. Another data type that does not have ownership is the slice. Slices let you reference a continuous sequence of elements in a collection rather than the whole collection. Here's a small programming problem. Write a function that takes a string and returns the first word it finds in that string. If the function doesn't find a space in the string, the whole string must be one word, so the entire string should be returned. Yeah, this function first word has and string as a parameter, but we don't want ownership, so this is fine. Yeah, let's and first word, third word, s string. Oh, yo, Rampona, thank you very much for the raid. Hello everyone. For those of y'all joining, I'm Lemma. I'm a chubby queer robot VTuber who both makes and plays games on stream. Tonight, I am learning how to use Rust. Having a lot of fun so far. Yeah, it is a really interesting language. Yeah, yeah. Okay. So, alright, so what are we gonna return here? This function first word has and string as a parameter. We don't want ownership, so that's one, but what do we return? We don't really have a way to talk about part of a string. We could return, like, the index of the end of the word? So, yeah, let's try that. So, let bytes equals s as byte for I and item byte iter enumerate if item equals space I. We can also and len. Yeah. Game called Rust 2, that's all I know about it, yeah. That technically makes it this a Rust. Oh my god. Yeah, because we need to go through this string element by element and check whether values of space. We'll convert our string to an array of bytes using as bytes. Next, we make an iterator, yep, of the array using iter method. Yeah, good to see you, Rampana. We'll discuss iterators in more detail in chapter 13. For now, know that iter is a method that returns each element in a collection, and enumerate wraps the result of iter and returns each element as part of a tuple instead. The first element of the tuple returned from enumerate is the index. The second element is a reference to the element. First strings are always UTF-8. Yep. This is a bit more convenient than calculating the index ourselves. Because enumerate returns a tuple, we can use patterns to destructure that tuple. We'll be discussing patterns more in chapter 6. So in that for loop, we specify a pattern that has I for the index in the tuple and the item for the single byte in the tuple. Because we get a reference to the element from .iter enumerate. Yeah, we use and in the pattern, right? Inside the for loop, we search for the byte that represents space by using the byte literal syntax. We find a space, we return the position, otherwise we return the length of the string by using slen. Now, if a way to find out the index at the end of the first word in the string, but there's a problem. We're returning a u size on its own, but it's only a meaningful number in the context of the and string. In other words, because it's a separate value from the string, there's no guarantee that it will still be valid in the future. Consider the program listing core 8 that uses the first word. Yeah. So, and let mute s from world. Let word equals first word s clear. Oh no! Yeah, word still has its value, but there's no more string we could get it from. So, like, that's not good. Yep. Alright, 9 o'clock. Yeah, I'll be wrapping up once I'm done with this chapter. But yeah, the program compiles without any errors and also do so if you use word after calling s clear, but because word isn't connected to the state of s at all, it still contains the value 5. Use that value 5 s to try and extract the first word out, but this would be a bug because contents of s have changed. Now to worry about the index and word getting out of sync, tedious and error prone. If we write a second word, yeah, that'd be even worse, yeah. So, let's slice. A string slice a reference to a part of a string, and it looks like this. Right? Yep. It's similar to taking a reference from the whole string, but with the extra O to 5 bit. Rather than a reference to the entire string, it's a reference to a portion of it. We can create slices using a range within brackets by specifying starting index, ending index, where starting index is the first position in the slice, and ending index, is one more than the last position. Yeah. So, yeah, we could do that, but then we need a return type, yeah. The starting index is the first position in the slice, and ending index is one more than the last position in the slice. Currently, the slice data structure stores the starting position and length. The slice corresponds to ending index minus starting index. So in the case of let world equals end s6 to 11, world would be a slice that contains a pointer to the byte at index 6 of s with a length value of 5. But yeah, also a data equals b range that includes b, if that's clear, yeah. A data equals b range, yeah. 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 Alright, 4, 6 shows with the diagram. Yep. Alright. Rest dot range syntax. If you want to start at index 0, you can drop the value before the 2 periods, okay? Same token, if your slices include the last byte of the string, you can drop the trailing number. That means that these are equal. You can also drop both values to take a slice of the entire string while still being a slice. Right? String slice range indices must occur at valid UTF character boundaries. If you attempt to create a string slice in the middle of a multi-byte character, your program will panic! For the purposes of introducing string slices, we're assuming ASCII only. For more thorough discussion of UTF-8 handling, there's Chapter 8, storing UTF-8 encoded text strings. Yeah. So they're covering that next, yeah. Also, .b range, then implicitly starts to 0, yeah. Right. With all this information in mind, let's rewrite first word to return a slice. And stir. For a string slice, okay. Then we can do and s, and s. Get the index or the end of the word in the same way as we did in listing 4.7 by looking for the first occurrence of the space. When we find a space, we return a string slice using the start of the string and the index of the space as the starting and ending indices. Now when we call first word, get back a single value that is tied to the underlying data. The value is made up of a reference to the starting point of the slice and the number of elements of the slice. Returning a slice would also work for a second word function. Now I have a straightforward API that's much harder to mess up because the compiler will ensure the references into the string remain valid. Remember the bug in the program in listing 4.8 where we got the index to the end of the first word but then cleared it? Yep. That code was logically incorrect but didn't show any immediate errors. Problems would show up later if we kept trying to use the first word index with an empty string. Slices make this bug impossible and let us know if a problem with our code much sooner. Missing the sliced version of first word will throw a compile time error. Alright? Right. Yep. Cannot borrow S is mutable. Also borrowed. Not borrowed S is mutable. It's also borrowed as immutable. Alright. Alright. That's a mutable borrow. Okay. Mutable borrow. Okay. Call from borrowing rules. Yep. Clear. Truncate the string, which needs to get a mutable reference. The println after the call clear uses the reference in word, so the mutable reference must still be active at that point. Rust disallows the mutable reference and the mutable reference in word from existing at the same time, and compilation fails. Not only has Rust made our API easier to use, but it's also eliminated an entire class of errors at compile time. String literals are slices, right? Recall that we talked about string literals being stored inside the binary. Now that we know about slices, we can probably understand string literals. So, type of S here is anstir. It's a slice pointing to that specific point of the binary. It's also why string literals are immutable, because anstir is an immutable reference. Okay. Knowing that you can take slices of literals and string values leads us to one more improvement on first word, and that's its signature. A more experienced recitation would write the signature shown in listing 4.9 because it allows us to use the same function on both string values and anstir values. Okay. It feels weird that they're, it makes sense why they're different, but the names are a bit confusing. Yeah, it's a string slice, we can pass that directly. If we have a string, we can pass a slice of the string or a reference to the string. This flexibility takes advantage of deref coercions, a feature we will cover in implicit deref coercions with functions and methods. Section of chapter 15. There's a proposal to call string stirbuff instead. I think, calling string stirbuff, I think, would be a good idea for such. It's like a different word, seem like a canonical string. Yeah. It would be a bit, it would be more honest. Yeah, I don't know what would be more confusing because reminds me of string buffer. Yeah, that's what it's short for because capital S string is basically a string buffer. Yeah. Yeah, just the question is do you want the short-term confusion of the stirbuff name or the long-term confusion of what what capital S string is actually doing? Rest string is a string buffer, basically minus janky JavaSync, yeah. C++ is string classes like that too, yeah. Finding function to take string slice instead of reference to a string makes our API more general and useful without losing any functionality. Yay! Because now you can do first word on slices too, yay! Other slices! String slices, as you might imagine, are specific to strings, but there's more general slice type too. Just so we might want to refer to a part of a string, we might want to refer to part of an array. Slice has type and I32, works the same way as string slices do by storing a reference to the first element in the length. You'll use this kind of slice for all sorts of other collections. We'll discuss these collections in detail when we talked about vectors in Chapter 8. The concepts of ownership, borrowing, and slices ensure memory safety in Rust programs at compile time. Rust language gives you control over your memory usage in the same way as other systems programming languages, but having the owner of data automatically clean up that data when the owner goes out of scope means you don't have to write and debug extra code to get this control. Ownership affects how lots of other parts of Rust work, so we'll talk about these concepts further throughout the rest of the book. Let's move on to Chapter 5 and look at grouping pieces of data together in a struct. Or, let's not, because it's 9 o'clock and I need to wrap up. Yeah, this has been a really, really good year. Yeah, I am super happy with just everything that's gone on. Yeah. Uh, Thank you to everyone for coming, for being part of my community. I've had a wonderful time. Uh, yeah, I've got some exciting. Yeah, May 2022 be bright. Yeah, 2022 be bright. Uh, yeah, I've got some exciting stuff coming up next year. Really exciting stuff. I'm planning to make a couple minor changes and one big, very exciting change. Yeah, with that, I think I'm gonna wrap up for here. I've been talking a lot. Adderall does that. My throat kind of hurts, but yeah. Thank you all. Let's see. Ooh, Huma's live. Yeah. Oh wow, a lot of folks are live. I'm gonna go raid Yuma, but yeah. Let's Happy New Year. Yeah. I've still got a few hours, but thank you very much. Hope y'all have a good New Year too. I want to go raid Yuma, yeah. So. Raid Yuma Yama no. Oh, I type of raid Yuma Yama no. Thank you all so very much for watching, Hangout, joining in. Thank you for a wonderful year. Thank you for just being a really nice community. Hopefully I'll be able to make it even bigger next year. Oh, thank you, Kikuchi. Yeah. No, it's funny. Yeah, hopefully next year will be even better. Gonna do my best. Yeah, thank you all for sticking with me for this long, and for the last time in 2021, let's get this raid started. I'm gonna send y'all over in 5, 4, 3, 2, 1. See you next year.